Okay, so let's get started. So hi everyone. My name is John Goold. I'm an associate professor here in the School of Physics, and I'll be the director of this new MSc in Quantum Science and Technology, which is due to start in September of this year. I'm here with Professor Stefano Sanvito, Chair of Condensed Matter Theory and Head of CRAN Institute at Trinity. So Stefano, you can say hi.
Hi everybody.
And we're really excited to bring forward this information session, and it's hopefully going to be full of useful information for potential students of the course. So let me first start by giving you a little bit of an overview of what we're going to go through today. So I'm going to first give a very kind of high-level overview of the course, the vision, and what we expect to pass on to prospective students in terms of both, teaching material, and also there's going to be, of course, a research/internship component, and we're going to hear all about that. We're delighted to have an industrial panel that's going to have a little bit of a discussion about the role of quantum technologies and their own particular roles in their companies. And that's going to be a little bit after I originally introduced the sort of course structure, and Stefano is going to chair that session. And then after that, there's going to be a bit more specific information on how you can actually apply formally to the course. And then we'll have a very important questions and answers session. Just a few housekeeping things. During the presentation, please just keep your microphone muted. And if you have specific questions, please do write them in the chat box that you have there in front of you. And the other thing is that, just so you know, we will be recording this session. So look, actually, we're here in the Schrödinger lecture theater in the School of Physics. So obviously Schrödinger is sort of a central character in the history of quantum mechanics. And this is a very historical room, because it was where Schrödinger himself gave his famous lectures on what is life. So I think that's a nice connection to this new initiative. So let me give you this very high level overview of the MSc, and remember to keep in mind during the question and answer session, if you have any particular questions for me or for Stefano on aspects of these things. So the course is drawing on initial funding from the Higher Education Authority in Ireland through something called the Human Capital Initiative. That allowed us to sort of fund the creation of this course and hire people like academics that will eventually teach on the course. I'll be telling you a little bit more about the people that are involved just in a moment. The key point is that we're trying to build upon the pre-existing expertise that's here in the School of Physics and associated centers. So you're really going to have lessons and courses and interactions with experts from various different facets of quantum science and technology. The other, I would say, particularly nice feature of this MSc is that we've made a particularly strong effort in its design to allow for sufficient flexibility in order for us to invite series of guest lectures from the quantum industry, both academics who maybe work in tangent with the industry, and also people who are directly working within the industry. And that doesn't just mean from very large sort of scale operations such as IBM and Microsoft, etc. You've heard about all of the activity probably in the quantum space that's going on there, but also we envisage and we hope, and we have various commitments from people from SMEs and startups all over the world. And hopefully at some point, in the future, we envisage that this will be a live interaction, but it will be some sort of hybrid setup depending on the availability of the speaker. This feeds into another, what I think is a very nice feature of the MSc. So it is a one-year talk masters, which is 90 ECTS, which means about 2/3 of the course 60 ECTS is going to be on taught material. I'm going to give you a little bit more on the details shortly after this, but there's going to be 1/3 of the course is going to be for a internship, if we can provide it, depending on the demand and depending on the number of people that are in it. But if we can't offer an internship, we'll gladly offer a very high-level academic project, either here in Trinity in one of the many groups, or with one of our academic collaborators, possibly even abroad. Okay, that is open for discussion amongst the students themselves, and we'll try to find a particularly suitable post or project for the individual students. That's the nice thing about this type of interaction. We want to have it very much close between the people who are delivering the content and the students. It's a blended MSc. It's a blended MSc not because of the current pandemic, but because by design, actually. So in year 1, there's going to be 10 ECTS, so 1 out of 6 of the modules is going to be a fully online interactive module, which is I'm currently developing with the Trinity online services. I'm going to tell you a little bit more about the details of that just in a second. The entry is for September, and of course this is a full-time MSc, so we don't envisage, at least at the moment, for there to be a part-time option. So they're all important things that I want to get across. One of the strong points that we have in this MSc is, educational programs and universities are only a function of the people that are contributing to it. So we have a very strong team of local people with an interest in quantum science and technology. I'm just going to run through the people you have here. We also have offered positions to 2 new assistant professors, so it's a little bit preliminary at this point. I can't tell you who they are until the fine details of their contracts is completed, but we'll be making an announcement very shortly on those people, and they're from different areas of quantum science and technology. So the people involved are myself, so I'll be the course director, at least in the first number of years. Stefano beside me. So Stefano is going to teach a module which is going to be closely liaising with industry. We have Paul Eastham, who's a professor here in physics with speciality in light matter interactions, open systems, polariton physics, etc. We have Professor Ortwin Hess. So Ortwin is a chair of quantum nanophotonics, so he's an expert in quantum optics, quantum materials, and he's also going to be delivering a module which is very close to his own research expertise. And we have a very recently appointed assistant professor, Alessandro Lunghi. So Alessandro is interested in molecular qubits, quantum machine learning, and will be implementing his knowledge as time goes by within the MSc. So we're currently working on that. So what are the subjects for this course that we are going to teach? So as I said, there's 90 ECTS, 30 ECTS is going to be a project or an internship, and we have 6 10 ECTS modules, 3 of which will run in the first semester and 3 in the second semester, and then in the summertime you'll have the project. What are these? So module 1, which I envisage to be a top-loaded module, I hope to deliver this content a little bit before other content in the first semester. This will be an introduction to quantum information science. So I think it's important to stress that we are not specifically aiming this course at people with physics backgrounds. We also hope to attract people from computer science, mathematics, and engineering. So we want to bring people up to speed with the sort of formalism of quantum information science and quantum mechanics that's the most useful for quantum technology. So that module I'm currently developing as an interactive module with Trinity Online Services. So for example, if you're a physicist that may have seen some of the topics before, I feel that that's a good sort of format for that. Whereas if you haven't seen some of that material before, you'll be able to have all of this stuff online and recorded and interactive sessions, etc. The other particular thing that we're aiming for here, having talked to people who work directly in quantum science industry, etc., is we really want to put a strong focus on classical programming skills, as well as, you know, learning about quantum computation, etc. So module 3, okay, the open systems module, this will be basically a module based on noise sources for very important single qubit and 2 qubit operations. But we envisage examining that course with a series of Python Jupyter notebooks, so that you can sort of get an idea how to do classical simulation of quantum systems. And those 2 modules will be running in the pre-Christmas period, okay? And will be examined by a combination of presentation and continuous assessment. So we're not going to have a written exam, but you'll have a combination of sort of problem sets, computational exercises, presentation, etc. Now, I come to module 2 because I think this is somehow a unique module in the course. So module 2 is one that Stefano is coordinating. And we envisage this module actually to run through both semesters 1 and 2. And the idea of that module actually is to bring external expertise to Trinity to teach to you. So it's a very unusual format, but we feel because, you know, things are rapidly changing, it's very good to have a module that you can kind of use to adjust to the needs and what's going on around us. So Stefano is going to take care of that. Then in the second semester, so post-Christmas, the 3 new modules will start. The first one is going to be coordinated by Professor Ortwin Hess, and that's going to be on quantum materials science and quantum photonics. It's going to be research-led, so he's going to tell you all about the exciting things in his fields. We're going to have a module delivered in part by Paul Eastham on the physics of implementations of quantum technology. So that will cover things like superconducting circuits, ion traps, NV centers, standard hardware platforms whereby quantum information processing now is done routinely in labs internationally. And then we're going to have a module on quantum computation and algorithms. And I would say that this is, you know, a module that follows on naturally from the module in the Introduction to Quantum Information Science that I teach. We are currently finalizing some details about the involvement with iCheck, which is the National Centre for Supercomputing in Ireland. So we're hoping to have their direct involvement in that module. And then, I mean, you can see that these 6 modules, there's no options here. I envisage that in the first year, we'll stick to this plan. And as the years evolve, we maybe have an option, different options emerging once content and personnel are developed. But the key point is that we want to play to our strengths. We want to be research-led. So we want to really kind of hone in on the expertise that is here and the expertise in our collaborators. And then the internship would be when the modules are completed. We're currently in negotiations with a range of SMEs, startups, larger companies, etc. We cannot guarantee everybody an internship. It depends on the numbers of the course. But as I said, if you don't do an internship, which of course will involve a write-up of what you did as part of that internship, you will do an academic project with one of us or one of the academic partners that you can ask me about. All right, so that's about all I've got to say for now. And so we're really excited to have an industry panel, and the industry panel is going to be chaired by Stefano. So I'm going to pass Stefano on, and he can tell you and chair this session.
Okay, thank you, John. So again, welcome everybody. Just before I kick off with the industry panel, just one quick remark. So why we have an industry panel in the first place? If you look at quantum technology is developing in university indeed, but much more outside the university in a very large group of companies. And this range really from small company to large companies. And just to give you the feeling of the scale of this operation, just last year in the US alone, about $500 million went in founding, growing new companies in the quantum space. So this is a large area. And of course, for us to develop an MSc, the first priority is to understand what this company needs. So who are going to be their employee of the future? So that's essentially the idea. And John and I went to this expedition to talk to companies. And today what we want to hear from them what they're doing and what they are looking for. So without any further ado, I would like to introduce my three panelists. So we have first Sabrina Maniscalco from the University of Helsinki, and also the CEO and co-founder of Algorithmiq, Joe Fitzsimmons from Horizon Computing in Singapore, and then Leonie Mueck from Riverlane, another quantum company based in Cambridge. So the way we're going to run this session, I'm going to ask a few questions to our panelists, and then so we really hear from them. So unfortunately, the ideal situation would be to have everybody in a room, and this is a chat, it's difficult over Zoom. So I would like to just to call one panelist at a time, and I will ask a couple of questions, and maybe at the end I will come back to all of them with a question that is more general for everybody. So I would like to start with Sabrina. If I can see you somewhere.
I am here. I don't know if you can see me, but.
Okay. Okay. Yeah, I can see you. Okay. Thanks.
Hi.
Thanks a lot, Sabrina. Thanks for being with us. So just very quickly, as I mentioned, Sabrina is the CEO of Algorithmiq, which is a pretty new company on the quantum horizon. So Sabrina is a fellow countryman of mine. She's Italian. She did her studies in the University of Palermo, and then she went really through an international career, touching many places in the European continent, ending up finally in Helsinki. So I guess my first question for you is, can you tell us a little bit what Algorithmiq does and how you get to that point?
As you say, the Algorithmiq is a young company. We are a startup funded about less than a year ago, actually. And we already went through our successful first round of seed funding. What Algorithmiq does is we bring quantum to life. So we are a company on quantum algorithms, and we believe that quantum computers without good algorithms are basically useless machines, especially now. Quantum computers, we know, will soon perform perhaps impossible calculations in the long future, when in the long road towards fault-tolerant quantum computing. But nowadays, especially for near-term devices, they really require some fine algorithmic craftsmanship. So we focus specifically on what they're called near-term quantum computers, the devices that we already have now, because we believe that they can already provide a lot of groundbreaking potential in many fields. In particular, we explored the field of quantum chemistry for the life sciences. And we focus on quantum classical variational algorithms. So we try to exploit not just the quantumness that is inside these quantum devices, but also classical means of complementing them in order to, for example, predict properties of small molecules that are fundamental in the drug development and discovery stage. So just an example of what we do has to do with a recent collaboration with IBM Quantum in Zurich, where we have been introducing a very important step in variational quantum algorithms, a type of quantum algorithms for near-term devices. And there we we proposed an algorithm which learned how to perform the best measurements in order to find the ground state of molecules or to solve variational programs. And then the last thing I would like to say is that we also have a sub-product of Algorithmiq that is called the QPlayLearn. It's an online platform containing multimedia resources to learn about quantum science and technology in a playful way. And our idea is that it is important not only to understand the physical concepts and the mathematics behind quantum theory, but also to build intuition and engagement. And we very often use games, videos, an approach which stimulates different types of intelligence. We have these three different ideas: play, discover, and learn. And nothing, at the moment we are just a small team, and we are in the process of expanding and at the same time preparing for the Series A funding round. This is everything about Algorithmiq I would like to share with you.
Thanks a lot. So maybe I'll just ask you a question which just connect to the very last part you mentioned. It's about the education and so on. And I'm just wondering, what are you looking for when you're looking for a quantum expert? So what of skill these people need to have?
Yes, it's a very important question, especially nowadays, that there is a great need for proper workforce. Many companies are looking for experts for quantum technology, science and technology. So I would definitely say that besides the knowledge in mathematics and in particular aspects that could be of quantum chemistry or some aspects that are general quantum physics, I think that it is particularly important to have coding skill. I think John mentioned before that everything which has to do with being able to code is really crucial nowadays, and also to provide some sort of multidisciplinary approaches and background, so to stimulate the students in different fronts, not just in the traditional way, but also in ways that may involve different fields of science, from finance maybe to chemistry and so on. And this is fantastic. I saw your presentation before. It's fantastic to do so by presenting some sort of real problems in an approach that is very close to what the industries need. So the modulo, I think, too, that was in your case is fantastic. So the connection with industry, the one that you are leading, and the ability to learn by real practical projects on real use cases of interest somehow.
Maybe, Sabrina, my last question. So you have which is connected to this one. You have a very international experience. Actually, all of you, in fact, has a very international experience. And I just wonder whether you can tell us a little bit, what is the value? Why actually is it important to have international experience in this field and see different places and love of different people?
Yes, I think that this is a fundamental skill nowadays. Number one, because it allows to getting used and getting exposed to different problematics, work cultures, ways of working. And in particular, I think it's fantastic for stimulating creativity and stimulating what I think is the main thing, that is the passion and the drive that people have in quantum science and technology in different groups. And then obviously it is crucial nowadays to have a proper network of knowledge and of collaborations. So the more international experience you have, the more people you are part of your network, and this gives you great possibility for your future career. This is always the case both in science, let's say in academia, and in business, definitely.
Okay, thanks a lot. So Sabrina, don't leave. I'm coming back to you at the very end. I just would like to bring Joe now. Let's see if I can see you.
Hi.
Oh, here you are. Okay. Oh, sorry. Sorry, the windows keep moving, so I'm not sure where people ended up. Just a quick word of introduction. So Joe actually is if you like, a product of the Irish education system. He did his undergraduate in UCD, and then he went for a PhD in Cambridge, and then actually really took off on the other side of the world, where he was professor actually in Singapore for a few years, and then he left academia to found Horizon Quantum Computing. That has been led since 3 or 4 years ago. So welcome, Joe. And I guess my first question is, what does Horizon do, and why?
Sure. So I mean, I should probably start out and say that I went to Oxford rather than Cambridge, but
sorry, I apologize.
Yeah, so what we do, actually, it's in some sense there's some parallel with what Algorithmiq do, but in another sense we're very different. So the company is about just over 2 years old at the moment, and what we do is basically to try to bridge the gap between conventional computing and quantum computing. So if you have any experience with quantum computers, there's a number of things you discover. The processors don't work as well as you hope they're going to. There's always all kinds of coherent errors in them. They're not doing exactly what they're supposed to do. It's really difficult to construct new algorithms. Quantum computers just work in a fundamentally new way, a different way from the way conventional computers work, and getting your head around how to construct an algorithm for that kind of processor is difficult, particularly for structured algorithms like Shor's algorithm that's good for factoring large numbers. These kind of things tend to be very difficult to come up with and need a lot of experience. And essentially, if you look at the programming languages that exist at the moment, they're really kind of like assembly languages. You're trying to program the quantum computer by specifying each and every logic gate that occurs during the calculation. And we try to bring abstraction to that. So we try to bridge it between classical and quantum computing. So we're building up programming languages for quantum computing at increasing levels of abstraction, with the goal of being able to ultimately compile classical programs to run on quantum computers. So that means taking source code that was written to run on, a conventional computer, a laptop, a cluster, something like that, automatically recognizing what causes it to be slow, what are the things that dominate the runtime, figuring out how do we replace these using quantum techniques so that we can get to the same result, but in a way that can really take advantage of a quantum processor to get there with far fewer resources. And how do we do this in a way that we can rapidly characterize a processor, understand where its defects are, and mitigate those errors as much as possible during the process. So that's what we've been doing.
Thanks a million. And so given your background, I can't resist to ask the question, how come that an Irishman ended up to lead a quantum company in Singapore?
Yeah, that's probably a good question. I mean, you kind of gave a bit of my background in the introduction. I started off in UCD doing theoretical physics, and I kind of wanted to work on an advanced technology, and I thought, I really felt that it would be cool to be part of the next kind of technological revolution. And I thought, actually, probably no one's going to let me do that if I don't, if I don't get a bit more qualified than the undergrad. So I moved over to Oxford, did a doctorate there. Then I was a fellow in Merton College for a while. And I was coming to the end of my fellowship there. And I was looking for a new job, was interviewing a couple of different places in Canada as well. And Arthur Eckert was a professor there at the time. And if you don't know him, he's quite famous in the field. He wrote a lot of early papers on quantum computing. He's one of the inventors of quantum cryptography. And he was also director, he was a fellow at the same college as I was in Oxford, but he was also director of the Center for Quantum Technologies in Singapore. So he suggested to me, why don't you apply to Singapore? And I'd visited once or twice before. It's really nice out here. So I decided to give it a go. Moved out here in 2010, initially at the Center for Quantum Technologies, and then also at a local university, built up a fairly large group. It was about 14 people at its height. And then about 2 years ago, a little over 2 years ago, I decided to quit. I'd gotten tenure not that long beforehand, decided I'd give up the position to jump into the startup space. Because, as you said, actually, the center of gravity for quantum computing is not necessarily in academia anymore. It started to shift more towards industry. There's a lot of really exciting things happening, both in big companies like Google and IBM and Microsoft, but also in startups. And actually, a lot of world leaders in the space have gone on to start companies. There's PsiQuantum and IonQ that's just gone public, and that are trying to build quantum processors. And as I saw it, it was my chance to have the biggest impact on the space. It was no longer in academia. That there were some problems to be solved, and now was really a critical juncture if quantum computing is to really become a meaningful technology, if it's to live up to its promise. And so myself and some others from my group decided to leave our academic positions, start a company, raise some money, and try to solve some of the problems that we see in getting to a world where quantum computers are a technology that's used, by industry every day.
And I guess so. That's a fantastic story, and I just wonder if people watching this, if they want to know how they can do that themselves. So I guess my question is, what skill and what sort of a profile you're looking for when you're hiring people in Horizon?
Sure. So we're probably a little bit bigger than Algorithmiq at this point. We have there's about 12 people on the team. Most of those come from a science background. So 7 are working on quantum computing in some form. They have quantum computing backgrounds. 5 of these have PhDs. On average, they average about 8 years post-PhD research experience. So generally, it's skewed towards very, very experienced researchers. But we also have some younger team members, including on the quantum team. So actually, Kyle Chu, who's probably our youngest member at the moment, he was initially an intern here, and then when he graduated, we hired him on full-time, and actually he's been a really valuable member of the team since. So he's been with us a little under a year at this point, but he's been really good. So it's most of these are coming from technical backgrounds, a lot of physicists, also a couple of people with computer science backgrounds. You know, aside from the quantum team, we also have software engineers, we also have UI UX designer, and then we have other people in other areas of the business, you know, marketing, communications, product development, and so on.
Okay, so thanks Emilio and Joe. So let me just, I come back to you as well, actually, at the very end. I'll just move to our last panelist. I mean, again, oh, John is going to find her. So this time we're fortunate to have Leonie Mueck. Now, Leonie has an interesting, also very interesting career, because she's a chemist graduate with a PhD in theoretical chemist, in quantum chemistry, if you like. And then actually she took a career in publishing. So she was editor of Nature for a few years. And then she decided to switch to, I guess, a new challenge, which was the one to becoming the chief product officer of a quantum company, Riverlane, which is this time in the Cambridge area, right? I got this right. So welcome, Leonie. Again, I mean, I guess my first question is, can you tell us a little bit what Riverlane does?
Yeah, of course. Thank you so much for the invitation. It's a pleasure to speak here. And yeah, Riverlane is a quantum software company also, like the other two, focusing on slightly different things. So we are based in Cambridge. We have about 30 employees now. We raised a Series A round just in January, quite a big one of $20 million, which we're very proud of. And we have a very specific view of quantum computing, which is that it all starts with the control system of quantum computers. So if you imagine the qubits, these very fickle things, right, that are incredibly sensitive to noise and to disturbances, they have a very, very big life support system of instruments and small elements of compute that keep them alive. And if we really want to develop algorithms and software, we have to start there and think everything from this control system. And so what we do is we look at how to best design this control system, the software for this control system, how to best deploy algorithms onto this control system. This becomes a very interesting problem in terms of kind of heterogeneous computing, in terms of FPGAs and ASIC design. And then how do we connect that back to applications that we might want to run? Our main motivation is quantum chemistry, similar to Sabrina Maniscalco, because we really believe that this is going to be the first big important application of quantum computers. So we try to think it end to end with a big focus on this control system and what it does and how to work with it.
Okay, thanks a lot. And I mean, I guess since you're the chief product officer, I think I really have to ask this question: where all the quantum industry is going? So what are we expecting in the next 5 years? I guess you need a crystal ball here, but let me ask anyway.
It's hard to make predictions, especially about the future, right? but okay, let me maybe give you a bit of an idea of what I find so exciting about it, right? I'm a quantum chemist, so I developed a couple of cluster theories, specific ones, in my PhD. And I loved that. It was wonderful, but you always run against a wall. Either you can do small problems with very high accuracy, very good predictive power, or you can do large problems, and then you have to make a lot of approximations, and quantum chemists have been very good at finding just the right approximations for the right problems. But you lose this predictive power. So what I find so exciting about quantum computing, obviously that's just a part of quantum tech, but let's talk about quantum computing. What I find so exciting about it is that there's this prospect of having predictive power for bigger problems. And what we've been seeing in the last couple of years is that the hardware is, finally maturing. We're seeing that it's not really a physics problem anymore. People can now make qubits. It's a scaling problem. It's becoming more of an engineering problem. There's kind of an inflection point that we're seeing in the industry. And then now we can really focus on some of the really hard, algorithmic software problems, how to deploy them on the hardware. And this kind of interaction between hardware and software, is starting to crystallize, is starting to clarify. And this is such an exciting place to be. So something that we're particularly excited about is that in the next couple of years, not quite sure how many, but couple of years, we will be hitting a 1,000 qubit frontier, right? And then the question is, what do we do with these 1,000 qubits? Can we do small error correcting codes? How do we bridge this kind of gap between the near-term error, the long-term fault-tolerant error? How do we really extract the value out of these quantum computers, in particular for quantum chemistry? So that's something we find incredibly exciting, and that's how we kind of see the industry evolving.
Thanks a lot. And maybe so let me ask the last question that will probably be asked to all the panels. So you're super welcome here, and of course you will be involved somehow actually in this MSc, and I'm just wondering whether you can tell us a little bit what is going to be your involvement. And the same question I would like to extend to Joe and Sabrina as well.
Sure. So would you like me to start? I can just make it start here. So yeah, we're very excited about this MSc, in particular because of its multidisciplinary aspects. So we really believe that in order to solve these important problems in quantum computing that extend to system-on-chip design, all the way to very mathematical questions and quantum error corrections, right? So, and quantum chemistry. Anyway, so you need a very multidisciplinary approach. You need lots of people on the team with lots of different experiences. And we see that this MSc kind of brings them all to a certain level of knowledge about quantum technologies and quantum computing, and also material science, which is great. So this is incredibly valuable for us as a skill. So we're particularly excited about being able to discuss with this multidisciplinary, group of people what they see, what their perspectives are on some of these problems, get some feedback on what we're doing and our thinking, really reality check this, and have all of these wonderful, young and fresh minds looking at these problems and starting an exchange with them. We're also very excited about the internship scheme. We have an internship scheme running every year. So for everyone there, if you don't decide to apply to this, you can still apply to our internship scheme, which is very successful and I hope wonderful for both sides and very productive. So that's also something we're very interested in.
Thanks a lot. So let me ask the same question to Joe.
So quantum computing has a workforce problem at the moment, a manpower problem, as Sabrina mentioned before. There are way more open positions than there are people to fill them at this point. So anything that further increases the talent pool is definitely to be welcome from our perspective. We've had really good experiences in the past with interns. I mentioned one example already where we've hired someone that was previously an intern with us, and that's something that I'm very excited about engaging with. It's also, while the whole world is shut down with COVID, it's maybe not so much fun, but as things open back up, Singapore is a really nice place to visit for a while. So yeah, we're definitely also very interested in the possibility of taking on interns.
Thanks a lot, Joe. And maybe last, the same question to Sabrina.
Yes, so as Algorithmiq, we are certainly, we would be very happy to have interns collaborating with your master, having interns in Algorithmiq in Finland. We are at the moment already having the first two interns of Algorithmiq. As I said, we are a young company. And also for us, what is important is that when the interns work well, we generally tend to ask, also inquire their interest in perhaps doing a PhD, a continuation with the internship in the company. So somehow we want this to be also a possibility for them to continue in their career, and ideally even with us. So we are very, very much into this type of longer term planning as well. And at the same time, if I can add something to this, because now I put the hat of the professor in the University of Helsinki. In Finland, we are starting, we have already started an institute called Institute Q. It's a national institute on quantum science and technologies. And within this institute, we are also starting master and PhD programs. And we would be delighted to have collaborations with other masters and future PhD programs in quantum science and technologies. So definitely we are interested in international cooperation and collaborations with you, both at the level of Institute Q and so this university level, and at the level of startups as like Algorithmiq in this case.
Okay, so thanks a lot. And so I would like to close then this industry section. So I would like to thank Sabrina, Joe, and Leonie for the contribution. And I just pass the ball back to John.
Yeah, thanks, guys. Great to see you as well. Okay, so yeah, so that was really great. And thanks a lot on my side as well to all of the three industrial panelists who I know in various different capacities as collaborators or as people I've met down the road myself in academia. Great to see you guys, and hopefully we'll see you in 3D at some point in Dublin, which would be brilliant. So without further ado, I guess there's some sort of more specifics now in terms of the application process itself. So I'm just going to go through them quickly, right? So, I mean, we, as I said, you know, are going to do our best to try to, you know, put everybody in the first couple of months of the MSc on a level playing field in terms of their, you know, ability to perform calculations in quantum mechanics. So for those of you maybe from a different background in physics, actually quantum mechanics is basically a theory about linear algebra. So, I mean, often engineers have much better at linear algebra than us. Okay, so it's a matter of sort of building on that. And we think that we can comfortably teach these topics to people with physics backgrounds, maths background, computer science or engineering backgrounds. If you're lucky, we might even take chemists, but just kidding. Of course, if you're from a chemistry background, you're welcome. We're thinking that for the type of material that we're going to deliver, that you should have, you know, a sort of upper second-class honors degree at 2-1 or above in the, you know, in the UK and Irish system. You know, we'll take every case on a case-by-case basis. So if you're a bit off that, I mean, you know, still apply, but, you know, we would have to see. The equivalent then, say, if you're coming from the US side, would be like a grade point average of 3 out of 4, 70–75%. This is kind of the ballpark that we'd be expecting, or the standard we'd be expecting for incoming students. So in terms of the general application requirements, is that you would also you know, be required to submit 2 academic references. Now, I understand if you're an undergraduate student, sometimes that seems a little bit strange. So, but I mean, I would say by often or not, I mean, your professors in your local university are always willing to write something nice about you. So please, you know, try to get that organized well in advance of when you expect to submit. Of course, then, you have to submit also on the portal your academic transcripts with a certified copy of your degree certificate, just to make sure that we know you are who you say you are, right? And if you're not a native English speaker, then some recognized certificate of proficiency in the English language, and some further documents like are required that you can find out about on the application website itself. The cutoff deadline for applications is the end of July. Okay, so try to prepare the documents and your references, etc., if you're interested, well in advance. And what I would say is that, of course, contact us as well. I mean, today is an information session, but we'll try to get back to you as soon as we possibly can with any additional questions or worries or concerns that you might have. Or let's say, any specific questions with respect to content, just get in touch. Get in touch with me. If I can't answer you, I'll put you in touch with somebody who does know the answer. Yeah, just in terms of the fees, etc. So I have actually something very exciting to announce, but I can't really announce it. So let me just say that one of the very large multinational companies has actually donated very generous funding for scholarships on this MSc. I can't tell you the details, nor can I tell you the specific company, but this announcement will be made extremely soon. So I would say within the next couple of weeks, you're going to hear about that. So there's going to be scholarships on offer that people will be able to apply for, okay? The fees, okay, range, they differ between European and non-EU entrants. So they're here, and this would be sort of commensurate with other degrees within Trinity College, Dublin. So it's roughly around the same ballpark. So if you have concerns about the finance side of things, please do get in touch as well. There are some other possibilities within TCD. And of course, with private loans, etc. And I can put you in contact with somebody who deals with those matters, right? So yeah, I mean, I'm just trying to think if there's anything else to address. I'm sure that if I haven't addressed something, it will be in any case addressed in the question and answer session. If you want to find out more, we have a website. You've probably seen the brochure, which we've sort of gone through a lot of the stuff that's in it already. Please email us on quantum@tcd.ie if you have these specific questions, worries, concerns, etc. And follow us on Twitter if you're on social media. So without further ado, thanks a lot for everybody for attending. Thanks in particular for the industrial panelists for essentially, I think they did a very good job in conveying the excitement that's around the field and the potentials, and they highlighted the need for interdisciplinary thinking, which we're trying to cultivate within the MSc. That'll be all for now. And let's switch over, and we have the question and answer session. So I would say for the question and answer session, you want to ask live, actually, it's fine. I'm going to keep a look out on the chat window as well, but if you can, I would actually quite like if people would just unmute and ask. I think it's more, in these times, you kind of, you look forward to any sort of social interactions beyond just speaking into a blank screen. So just fire away. Maybe you can raise your hand and we'll address them one by one.
And if anybody wants to submit questions through the chat box, I'll also be keeping an eye on adding links, if I can help. So does anybody have any questions? We have one question there from, was it Oren?
Yeah.
Hi, Oren.
Hi, so this is probably just a bit more logistical, but for just the application itself, do we need to upload a degree certificate if we have not yet graduated, for people who are in final year undergrad now, or is the transcript fine?
So I think Niamh McGoldrick is the right person to answer this question.
That's fine, Oren. For the moment, all you need to do is upload your grades from previous years. And what might happen, depending on when your degree certificate is available, you might get what's called a conditional offer. So a conditional offer is based on you getting a 2.1 or above in your final degree, and if you have that grade, then we'll give you a full offer for September. So you can apply now, and you can apply with your grades from previous years.
Perfect. Thanks so much.
Thanks, Oren.
Any other questions there?
Yeah, I was just going to ask, is the course likely to be in person in September? I understand you probably can't give a definitive answer, but what's the rough indication?
Yeah, so that's a good question. And I specifically didn't address it because I was expecting it in the questions and answers. It's a question that's been posed to me several times during the year. Look, I mean, this is something that I have personally discussed and been worried about, actually, and discussed many times with the school executive, to the point where they're probably getting annoyed with me about it. But so look, I mean, I would say that it depends on the numbers, right? But it's likely, you know, that the number of students that we get for the MSc is manageable under 2-meter social distancing restrictions. Now, it's not guaranteed, because as we've learned in the last 15 months, there's no particular way of making predictions on what will happen. We should have a better idea next month when Simon Harris, who's the Minister for Higher Education and Research, makes an announcement about the start of third level in September. However, let me just state the following, that all people involved on our side are really, you know, trying our best to accommodate the largest part of live interactions. So, for example, you know, we're sitting here in one of the large kind of lecture theatres within physics, and the head of school, Jonathan Coleman, has told me that in the event where they have to, you know, choose which teaching is going live, that the MSc will be given top priority to go ahead in live. And of course, if there's particular issues, you know, health issues, etc., that somebody's concerned about, get in touch. Everything will be recorded anyway, okay? So, but my feeling is that the live component, if we absolutely can at all, will be there. So we'll try our very best to make this happen, and we'll be given top priority for the school to do it that way.
Yeah.
Brilliant, thank you.
Any other questions? I'm just keeping an eye on the time. It's 4 minutes to 1 o'clock, and I'm conscious that people might have other plans. So what I'm going to say is I'm going to put in the email address again into the chat. And if anybody has any questions that they would like to submit directly to us, we will get back to you, but we will also encourage people to keep an eye on our FAQ page on the Quantum website, and we will be uploading answers as questions come into that. So hopefully either directly from us, from the team itself, or by keeping an eye on the website, you'll get your answers.
Niamh,
okay?
Sorry, Niamh, could I just ask an obviously planted question, not for me, but maybe useful for people to know?
Yes.
When is the deadline for applying?
The
July
31st.
31st.
The 31st of July. And I just want to say one thing maybe which wasn't covered. I mean, I should have actually said it at the start, but let me just get it in now, is that it's often asked, you know, what can I do after the MSc, right? And I've been thinking about this, you know, and we've heard from like the startups today and the SMEs, etc. But of course, you know, you may not be interested in joining the quantum industry, and that's okay too. I mean, I would say the MSc itself provides a fantastic springboard to go on to do, you know, to continue on with higher level education, like a PhD program in the States or in Europe. And I would say that, you know, a lot of European universities having an MSc before you do a PhD is the sort of default thing anyway. So it will be a fantastic platform for that, because, you know, we'll have high level subjects that you'll be now familiar with. And also, I mean, it's just a fantastic intellectual endeavor as well. So you may decide to go into a tangential field or whatever afterwards. So, you know, in that, I often get asked about what are the prospects afterwards, but I would say, you know, there are multiple. I mean, it's not just, you know, unidirectional really, you know, and I think that's important to say, and I should have said it at the start. So, yeah.
Great. Well, can we just get everyone to wrap up, and we'll say our final thanks, if that's all right. And thank you again to our speakers. And as I said, if you have any questions, please do get in touch at quantum@tcd.ie, and we will get back to you as soon as we can.
And I just want to say a personal thank you to Niamh McGoldrick, because me and Stefano had a very easy job, really just sat in front of a screen. And I think Niamh really organized all this. So thanks a lot, Niamh. Appreciate it.
Happy to help, guys.
Bye. Bye, everybody.